Welcome to Decode It, a podcast series helping understand more about computer technologies and its beginnings. I'm Ashley Griffin, involved in IT from the 1980s, first with the Atari ST, then onto computer networks in the early 1990s. RAID, an acronym for Redundant Array of Independent Disks. Founded in 1987 by David Patterson, Garth Gibson and Randy Katz at the University of California. Although RAID officially was documented in 1987, various forms of its store methods were used as early as the 1960s. Using more than one drive in a single storage volume increases capacities, however also increases the possibility of failure. Two drives joined together has twice the risk of failing. The net result is a total data loss of the whole data volume. RAID facilitates redundancy when combining drives together. Data store methods are denoted by the RAID name and denote protection method and read-write efficiencies. Traditional hardware RAID requires all drives be identical, including firmware used on the drive. It's very processor intensive as extra data is created called parity, which is then stored in the RAID volume in a specific structured format. In the event of a failure, the parity is used to recreate the data the lost drive had, while keeping the volume online and usable. The different types of RAID are RAID 0, data striped over all of the drives. The total capacity is all of the drives added together. Any drive failures will result in a total data loss. RAID 1, mirror. Total capacity is the size of a single drive. Two drives are a duplicate of each other. Either drive can fail with no data loss. RAID 2, bit level striping. It's deprecated, no longer used. RAID 3, same as RAID 2 except byte level striping. It's also deprecated. RAID 4, same as RAID 2 and 3 except block level striping. This is still used by a few manufacturers, some with proprietary store methods. Its advantage over RAID 2 and 3 is data can be found on a single drive. RAID 2 and 3 has to read all of the drives to collect the data. RAID 5, distributed striped parity. Requires a minimum of 3 drives. The total capacity is the sum of all the drives minus 1. Any drive can fail with no data loss. RAID 6, distributed striped double parity. Requires a minimum of 4 drives. The total capacity is the sum of all the drives minus 2. It's identical to RAID 5 except 2 drives can fail with no data loss. RAID 5 and 6 are common today. RAID 6 has way more overhead on the CPU as it creates 2 sets of parity. Both RAID 5 and 6 suffer from the same problem of long-term reliability. Should a RAID 5 array of 10 drives have a failure, it has to read all 9 to rebuild the data. It's not uncommon to have more than a single drive fail at any time. The loss of a second drive while rebuilding will result in total data loss. RAID levels can be combined, such as RAID 0 and 1, which would be 2 groups of identical RAID 0, then mirrored RAID 1 together. This type of store setup is used by systems that require very high throughput, such as databases and broadcast media servers. RAID has many other features not covered here, such as redundant, hot, live and cold spare drives. Rebuild times are long. A 20 terabyte RAID 1 mirror takes around 5 to 7 days to rebuild. It is, however, always live and available for use during the rebuild at a reduced efficiency. Grifcom mostly use RAID 1, having 2 disks to carry the same data. It benefits from no CPU utilization and double the data read speeds. My first contact with RAID was working in the UK as a network administrator in 1997, a small server running a database. Then in 1999, a large food manufacturing plant with 300 and more staff, a single compact server with a RAID system using SCSI hard drives. The backplane the board drives connect to had failed, taking over a day for Compaq to replace. RAID is not an easy technology to master due to its implementation being different for each manufacturer. LSI, purchased by Avago, then Broadcom, were the largest as they made CPUs for RAID used by many large manufacturers including Hewlett-Packard, Intel and Lenovo. Intel's first attempt at RAID is called Matrix. It's soft RAID in that an installed operating system is used to rebuild the RAID instead of a dedicated hardware. A failed drive normally results in losing the whole volume in the years that we had seen it in use. Intel now has hardware version called ROC, an acronym for RAID on Chip. It's built into the server CPUs and requires ROC compliant motherboards to connect the drives to. All our servers use hardware RAID with a special long life SSDs, solid state drives configured as RAID 1 mirrors. Entry level hardware have capacities for up to 3 virtual servers. We use the same hardware and technology for our proprietary desktop and server backup solutions, remote PC support services and network monitoring proxies. When the server is in use at remote locations where obtaining replacement drives can take longer, such as Tanzania and the Maldives, we would use RAID 6, which allows for double protection, buying time to find replacement drives. Our server hardware also talks to the connected UPS power supply, alerting us when power fails. When the battery is depleted, the server is put into a special state. When power returns, the restart is quicker with no data loss. Thank you for spending some time with me. Subscribe to see more in the Decode It series.